Hello friends, myself Anil Kumar Singh. In this tutorial, I will explain how to perform inverse Fourier transform of noisy signal, time domain data. Okay, it means how to convert frequency domain data into time domain of noisy signal. Okay, so just open the Matlab tool. See, this is the user interface of the Matlab. I have already coded noisy signal in inverse Fourier transform of noisy signal. Okay, I will explain the code line by line. Okay, see first section will clear the workspace and command window. CLC closure clear all, and next section I have defined the parameters to generate the sinusoidal signals and FFT point also I have set it to perform the FFT and inverse FFT, and I have defined the time vector. Next section I have generated the sinusoidal signal, and in next section I have generated the noisy signal. I have already explained in the previous lecture. If you have not watched, please go through the previous video and then watch this video. So here I have simply added random noise to sinusoidal signal x1t. X1t is the sinusoidal signal, and I have added this random noise to sinusoidal signal to generate the noisy signal. In this way we can generate the noisy signal. So next step is convert this noisy signal time domain data to frequency domain. For doing this, first do the FFT by using Matlab function FFT keyword and passing this noisy signal data, and also pass the FFT point. It will generate the FFT domain. It will convert time domain noisy signal to frequency domain. Okay. Now next section is to convert frequency domain noisy signal data to time domain data. So I have used IFFT. This is the Matlab function. This function will convert frequency domain data into time domain data. So this function takes FFT data as well as FFT point, inverse FFT point. I have set it here 1024 in the parameter section, and FFT data I have taken from the earlier section. Okay. So these are the two inputs to the inverse FFT function, and it will generate the inverse data, inverse time domain data. Okay, and simply I have plotted here T comma IFFT, and I have given the title as inverse Fourier transform of noisy signal. Okay, and X level I have marked as time in second, Y level marked as amplitude in a linear value. Okay, just control S to save it and run the simulation. Okay, just I am rearranging the figure and then I will explain. Okay, so I have generated 4 signal. First figure, see figure 1. First figure is sine signal. I have generated one sinusoidal signal, and second signal is noisy signal. Noisy signal I have obtained from the sine signal by adding the random noise to this sinusoidal signal. So noisy signal is sinusoidal but distorted form. Because of this is I have added some random noise to sinusoidal signal. So we can see here easily. Noisy signal is nothing but sinusoidal along with noise. Picture sinusoidal fluctuation. Okay. Then I have performed this IFFT on noisy signal to generate frequency domain data. See here, magnitude y-axis shows the magnitude of IFFT data, and x-axis shows the frequency, negative frequency as well as positive frequency. Okay, so this one is 50 Hz sinusoidal signal. So this component is 50 Hz, and this one is mirror image of this one. Because of sinusoidal signal is real signal, I have taken as a real signal. So FFT is symmetric. Okay, that's why here mirror image formed in negative side. Okay, see here, whatever noise I have added to the signal, that FFT of that noise signal is look like this. See, just I am zooming it to show clear noise spectrum. See, these are the noise spectrum, FFT data of the noise, random noise. Okay, just zoom out. See, so this spectrum has sinusoidal signal along with noise signal. We can clearly see in the FFT frequency domain. Now next section is to convert frequency domain data into time domain. So this one figure 4 is output of the inverse Fourier transform. It means this one is this frequency domain data converted to time domain data by taking the inverse FFT. Okay, see, x-axis is time in second, y-axis is amplitude in linear value. Okay, so this output of inverse Fourier transform should be same as input of the frequency domain data. So input of the frequency domain data is this one, figure 2. So this figure should be same as this figure, and we can clearly see both the figures are same. So inverse Fourier transform we have completed successfully. Okay, thank you so much for watching my video.